Tony, your fourth Matsuura MX-850 5-axis machine, seated right here. Now the clever thing about this installation, obviously the machine is very sophisticated, but what you're doing here with the work holding is something very, very unique. Just explain what we've got here on this table, on this 5-axis table.
Well, what we've got here, we've got a fixture that's been 3D fixture printed to support a low-level production part, which will become a production part, but we've been able to produce the prototypes very, very quickly, and I mean quickly. From design release, 24 hours, we've got a fixture with a part on the machine ready to cut.
Now if I look at this part, then I'm going to look at how I would do this if I didn't 3D print this fixture. So firstly, you'd have to design it or order the material, design it, machine it, all of those aspects, wouldn't you? And that could take you possibly, what, a week, a couple of weeks to get it through?
Yeah, 1 to 2 weeks, depending on material supply. Then you've got to make it in your tool room or wherever.
And it would also look very different to what you've come up with as the finished article as well, wouldn't it? Because here, you can print this you can re-engineer it to the best possible solution.
We can machine a part or 3D print a part, which is almost unmachinable. So we can put structural strengths in it that you would not normally be able to do with a normal part.
So let me just be clear on this. So you're using your new HP 3D printer from Matsuura to actually print the fixtures and the work holding for a lot of your prototype and production parts. But the benefit here is you can turn this round in 24 hours.
Yeah, that's quite correct. Yeah, 24 hours. Normal route would be probably a week at least. Material supply, you might be into 2 weeks. So from release of design, 24 hours, we're ready to go.
What I want to try and find out as well is some of the negatives here, because I look at these things and, you know, it's fabulous that you've achieved this, but is there not, is there a compromise anywhere? Is the material weaker? Do you get the same surface finish when you hold a part? Is it secure?
The plastic actually absorbs vibration, so our tests have proven that it's sometimes better than mechanical metallic fixtures because it absorbs the forces of the cutter.
Isn't it?
Yeah, well, this particular fixture, if you look at what we're doing, we can actually build webs in there to stop swarf accumulation, and you can see this part on this 5-axis machine, there's no swarf traps. If that was a normal conventional fixture, it would probably be fabricated, maybe a bit of fabrication and machining. We're able to get away from that, and we can build all sorts into the fixture.
What about holes, air lines, and all of those?
And capillary holes in to support wash or air pressure. We've tested it with air pressure up to 5 bar, and that's been very successful. We can even put hose connections on, which we can build in. All the things that are, it's unimaginable what you can do with plastic.
What about the weight of a part? If you had, let's say, I know we've got a rather small component on here, but what if it was much bigger? What if it was 40, 50 kilos? Because these tables on these machines can accommodate a lot of weight and large components.
We could probably, if it was a really large fixture, we'll probably build some metallics into it to strengthen it. That's where we a hybrid fixture.
Ah, okay. So you would print part of the fixture, but then introduce metallics where you needed it.
So where we've got, say, tapped holes that had with a lot of torque on, we'd build in a bush that was in the fixture, pull from the back, or we'd put counterbores in where we'd insert metallic items.
I mean, it's incredible, really, Tony. How much time has this saved BCW Manufacturing, and how much of a difference has it made?
For time, it gives us the ability to go from prototypes to first-line production parts within weeks rather than months.
And I suppose even if you're challenging for to win a new order, you don't want to necessarily have to build a fixture just to do a prototype part where you might not win the business here. No. If you can print it in a day, it's neither here nor there.
It gives us an advantage over quoting as well, because we can print a fixture and we can actually dry cycle a part and actually cut it without and get a true cycle time. So when we quote, we are competitive.
And in your experience, a metallic fixture made in a tool room, people may say it might be more robust, but I get your arguments as to why this may equal it. What about the longevity of it? How long is a fixture like this going to last, in your opinion, and how successful have these been so far?
Well, we've not actually put fixtures into full-time production yet, but certainly from small batch to medium batches, we don't see a problem with plastic fixtures. The metallic items, where we say the hybrid parts, are important because obviously it's plastic, threads will wear out. So it's how we engineer the part, the model, and we put inserts in to protect that.
And I also think one thing that just jumped into my mind there is that the flatness, when you're printing, I'm not quite sure on what the flatness you can achieve on an HP printer is, but could you not just machine the...
We can put an allowance on, we can leave a plastic allowance on, and we can machine that off on the machine. So for datum creation, where we want an accurate size from the top of the table to, say, on that part to the top of the fixture, we can machine that to microns.
What about the threads? Last point from me. I mean, are they not easier to strip, easier to wear?
It all depends on what diameter they are. If it was an M12 thread, anything from M8 up to M20, it's not really a problem. The smaller threads can be a problem, and that's where we will put inserts in, because obviously if you're screwing cap heads in and out, they will wear out.
Overall, has this been a real eye-opener for you?
It's made us rethink how we would normally manufacture parts. It's very exciting because what we can do, we can take a design, a concept, and we can try it out before we go into a full-blown fixture. It's really exciting.